Hi everyone. So in this video, we are going to discuss about chapter 12, which is the nuclear reaction. So let's go straight away to the question. So a deuterium nuclear reaction is given by. So we have here deuterium plus deuterium plus deuterium, and the products are helium and hydrogen and one element X, which is we don't know yet. So they already gave us the atomic mass unit for every single nucleus. All right. So this, let's determine X. So X is actually, so we have 2, 4, 6. This one is 4, 5, so means that we have 1, 2, 3, 2, 3. Oh, don't have to do anything. So that one is 0, proton is 0, means that this is actually nitrogen. Sorry, neutron. So X is neutron. Okay, next, number 2, state the type of nuclear reaction. So the nuclear reaction is actually, because we are talking about deuterium here, so it's actually a fusion reaction. Okay, so this question did not ask for us to explain, so we don't have to do anything. But if you were asked for you to explain, then you can see that deuteriums are like nuclei. So they tend to fuse in a reaction rather than split. So in this case, if it's split, it is called fission reaction. So done. That's question number 2, and that's the answer. Let's go to the question number 3. Number 3 is quite tricky, so that's why I like to make a video about this one. So it says here, calculate the mass of deuterium required to produce 8.2 gigajoule of energy. Okay, so here's the plan. This is a very lengthy calculation. So number 1, we have to find energy for one event. And we know that in this case, we can see this is one event. And in this one event, we can see number of deuterium nuclei are 3. 3 nuclei. So 3 nuclei. Next, the plan is to find energy for one nucleus. The next step is find how many nuclei, or you can say N, required to produce whatever that the question is asking, which is 8.2 times 10 to the power giga is 6 joule. Yes, and then lastly, we use this equation, m over molar equals to n per Avogadro's constant. Yes, that's the plan. So let's get to it. So the first one, step number 1, we have to find the energy for one event. Let's do. So the first thing that we have to do is find the mass defect of this reaction. Mass defect is delta M. So summation of mass before reaction minus the summation of mass after reaction. Yes. So let's see, mass before reaction, we have 3 mass of deuterium here, right? And minus the mass of helium, and plus what? Helium, and then we have hydrogen, mass of hydrogen plus mass of neutron. Yes. So 3 times the question gave us the mass atomic unit for deuterium is 2.014102 minus Okay, 4.002603. I don't know why did I have to make this bracket. It is so totally unnecessary. So 1.007277 plus 1.008665. Okay, so the answer you're going to get is 0.023761 U. Okay, since the question is asking for the energy in joule, so we have to change everything in joule. So I'm going to change it into kilograms first, the AMU, atomic mass unit. So the answer is 3.9443 times 10 to the power of negative 29 kilograms. So if those of you who still cannot remember what is the unit conversion between AMU and kilograms, here it is. Times 10 to the power of negative 27 kilograms. Okay, for one atomic mass unit, it is equivalent to 1.66 times 10 to the power of negative 27 kilograms. So that's it. Next is for us to find the energy. Energy released for one event. I'm going to put it here Q3 because we have 3 nuclei of hydrogen, of deuterium. So delta M C squared equals to 3.9443 times 10 to the power of negative 29 times 3 times 10 to the power of 8 squared. Yes. So the answer should be around 3.5462 times 10 to the power of negative 12 joule. If you found there's any different, a little bit of difference here, it is considered okay. Right, next we continue. So after we get the energy release for one event, we're going to continue. We know that one event requires 3 deuterium. So we can see that for 3 nuclei of deuterium produce 3.5462 times 10 to the power of negative 12 joules, right? It means that for one nucleus of deuterium can produce, I'm going to put it here Q1 because this is one nucleus. Okay, so 3.5462 times 10 to the power of negative 12 divided by 3. So you're going to get 1.1833 times 10 to the power of negative 12 joule. Yes. From here, and then the next plan is to find the number of deuterium, deuterium nuclei required to produce whatever given in the question, which is 8.2 times 10 to the power of 9 joule. So we can say that number of nuclei of deuterium just now divided by 1, because 8.2 times 10 to the power of 9 joule, because we know that one nucleus of deuterium produces this much. So this one deuterium is equivalent to 1.833. Sorry, wait, I'm gonna put it properly. Okay, 1.833 times 10 to the power of negative 12 joule. So number of deuterium required for 8.2 times 10 to the power of 9 joule is actually 6.9298 times 10 to the power of 21 nuclei of deuterium. Yeah. So it's still not end here. We have to find, finally we can find the mass required for producing 8.2 times 10 to the power of 9 joule. So we can use this equation. Moles and Avogadro's constant. So M, this is 2 times 10 to the power of -3, because this is deuterium, right? So you know how to find this one. So this is 9.6, this one 9.6298 times 10 to the power of 21 divided by Avogadro's constant, this. And you can finally get the answer. It should be around 2.301 times 10 to the power of -5 kilograms. That's how we do. So this is the overall view of question number 3. So I hope you can understand my video, and if you like it, give it a thumbs up, and if you have any question, comment at the comment section below. Thank you everyone.